Let's look at this problem. We are asked to add 1/14 or find the add 1/14 to 52 over 63. The first thing to do is to prime factor each denominator. So 14 is 2 times 7. 63 is 7 times 9, but 9 is not prime, so we're going to say 3 squared times 7. The next step is to form a product of the different factors. That would be 2, 3, and 7. The last step is to find the exponent on each of these factors. Let's look at the digit 2. I see it once here. Don't see it at all there. So the most I saw it in either place is once. The digit 3, I don't see it. I see it twice here. So the most I saw it is twice. That's the exponent. The digit 7, I see it once here and I see it once there. The most I saw it in either place is once. So that's the power. The LCD is the product of these three factors. 2 times 9 times 7. 9 times 7 is 63, and 2 times 63 is 126. The next problem asks us to subtract one fraction from the other, 1/9 from 7/12. We need a common denominator. Let's go through my three-step process. 9 is 3 squared. 12 is 3 times 4, which is really 2 squared times 3. Form a product of the different factors, which are 2 and 3. And to make it the LCD, find the exponent in each of the factors. The factor 2, I don't see here, but I see it twice there. And the factor 3, I see it twice here and once here. The most I saw it is twice in one place. So the LCD is 2 squared or 4, 3 squared or 9, and the product 4 times 9 is 36. So now we need to change each of the two original fractions into new fractions whose denominator is 36. Well, it's the opposite of reducing. How many times does 12 go into 36? I think it goes in 3 times. So let's multiply this fraction by a 3 over 3. That's a 1 factor. 3 times 12 is the 36, but 3 times 7 gives me the modified numerator. How many times does 9 go into 36? It goes in 4 times. So I'm going to multiply the original fraction by 4 over 4, a 1 factor. 4 times 9 is the 36, and the modified numerator is 4. Now that I have the common denominator, I have two fractions with the same denominator, I can keep the denominator and subtract from 21 the value of 4. And if I do that, that's going to give me 17 over 36 as the final answer. Here we would like to subtract y over 11 from 5. Well, we need a common denominator, which is obvious that the original problem can be written as 5 over 1 minus y over 11. So the common denominator is 11. The LCD is 11. To change 5 over 1 into the proper denominator, I need to multiply top and bottom by 11. So therefore, the denominator becomes 11, which is what I want, and the numerator becomes 55. Second fraction, we don't have to do anything to, so it's just y over 11. Keep the denominator 11 and subtract y from 55. They're unlike terms, so we can't physically do the subtraction. It's going to be 55, take away y, all over 11. In this problem, we want to simplify a complex fraction. A complex fraction is a fraction made up of fractions. A simple fraction is what we want, is made up of a whole number in the numerator divided by a whole number in the denominator. So the first step is to combine like fractions in the numerator. I think you can see that the common denominator is going to be 35. Therefore, to change 2/5 into 35ths, we must be multiplying by a 7 over 7, a 1 factor. Therefore, the modified numerator is 14. And to change sevenths into 35ths, we must be multiplying by 5 over 5, a 1 factor. So the modified numerator is 20. So we're going to continue with that numerator, keeping the denominator, which is 35. We're going to add the numerator as 14 plus 20, which is 34. We're going to do a similar thing in the denominator. Common denominator in the denominator is 28. Changing fourths into 28ths, we must be multiplying by 7 over 7. So the modified numerator is 7. To change sevenths into 28ths, we're multiplying by 4 over 4. The modified numerator is 8, giving us a result in the denominator of 15 28ths. We now have a single fraction divided by a single fraction, but we need to simplify this still is a complex fraction. So we're going to take the numerator 34 35ths, change division to multiplication if I flip the denominator 28 over 15. I'm not going to multiply right away. That will make some rather large numbers. I'm going to see if I can reduce first. And I'm looking at this. I'm looking at the problem. And, oh, I do see 7 to the 28 goes 4 times, and 7 to the 35 goes 5 times. I don't see any reduction this way. So I'm just going to say the final answer is whatever 34 times 4 is. Getting out my trusty calculator. Looks like it's 136 over 5 times 15. I think that's 75. And we're allowed to write a fraction, and that is the final answer. We need to follow order of operations on this problem. So we're going to go inside the parentheses and get a common denominator of 8. So we want this to be 8s, and we want this to be 8s. To get 5 quarters to be converted to equivalent fraction in 8ths, we must be multiplying by 2 over 2. So we have 10 8ths. And to convert halves into 8ths, we're multiplying by 4 over 4. So this becomes 4 8ths. Okay, common denominator is 8. I'm going to subtract the numerators. 10 minus 4 is 6 over 8, divided by 2 over 9. I do see that this can reduce. I'm holding off, though, at the moment. I'm going to write the fraction 6 8ths, change division to multiplication, flip the second fraction. That's 9 over 2. I can reduce vertically, or I can reduce diagonally. It doesn't really make a difference. 2 and a 2, 1, 2 and a 6, 3. I have no further reduction, so the product is going to be 27 over 8.